So before studying this, we should know about the momentum. What is momentum? Suppose any object which is having mass m, any object which is having mass m and it is moving with certain velocity, then we can say that the object have a momentum. Suppose this is the object which is moving with velocity v in horizontal direction, then here mass of the object is m and object is moving with velocity v, then we can say that object is having some momentum, that is equal to P is equal to mass into velocity. This is called the momentum of the object. Any object which is having mass m and it is moving with certain velocity, then that it means the object have some momentum, and the magnitude of momentum will be equal to P is equal to m into v, where P is representing the momentum and v is the velocity of the object and m is the mass of the object. As here velocity is vector quantity and mass is scalar quantity, so we are multiplying mass into velocity, then we will get a vector quantity. So it means we can say that momentum is also a vector quantity. So object is moving with certain velocity which have mass m, then momentum of the object will be m into v. So here mass of the unit of the mass is kilogram and unit of the velocity is meter per second. It means we can say that the unit of the momentum will be kilogram meter per second. This will be the unit of the momentum. Now comes to the force. Suppose any object which is in spherical shape. Now we are applying a force on the object, then what we will see? The shape of the sphere got deformed. Why it got deformed? Because there is force acting on the object which change the size of the which change the shape of the object. It means force have ability to change the shape of the object. Now here in the diagram we can see that we throw a ball, then what happened? Ball moving in horizontal direction as well as in downward direction. Why it is moving in horizontal direction? Because object got some velocity, due to which object is moving in horizontal direction, but in downward direction object got the acceleration due to gravity, due to which it is moving in downward direction. So it means here mg is the force acting on the object which change the direction of the object continuously. It means force can change the shape of the object, force can change the size of the object, force can change the direction of the object. So it means force is a strength which can change the shape, size or direction of the object, which can change shape, size, direction and change in the state of the object, that is called as the force. So Newton describes the force in three laws, that is called as the Newton's law of motion. Any object which is moving with certain velocity or which is moving, then there is a three kind of force may be acting on the object. That's why object is moving or changing its direction or changing its shape or changing its motion. So it means there is a force acting on the object, that is called the Newton's law of motion. Newton given three law. The first law is known as the Newton's first law of motion. Suppose any object which is in rest, any object which have mass m and it is on the surface of the ground and it is on the rest. Now we applied a force, then what will happen? The ball will start to move. It means any object which is in rest, if we are applying a force, then only object will move, otherwise it will not move. If object is in motion, then it will keep in motion. If we are applying an external force, then what happened? Object either may increase its velocity, or it may decrease its velocity, or it may comes to rest. So it means we can say that if any object is moving with certain velocity, or any object is in motion, then it will keep in motion. If object is in rest, then it will keep in rest unless and until any external force is not applied on it. It means object have a tendency to stay in a situation, means object do not want to change its situation. So it means we can say that object have a tendency to stay in its state unless and until any external force is not applied on it, then that is known as Newton's first law of motion. It means we can say that Newton's first law of motion is a tendency of an object to be in same state. Means object, if object is in rest, then it will keep in rest. If object is in motion, then it will keep in motion, if unless and until any external force is not applied on it. That is called as Newton's first law of motion, as the object having a tendency to stay in its state, so that is called as the law of inertia. It means Newton's first law of motion is also called as law of inertia. So in simple word, we can say that if the net external force on the body is 0, its acceleration is 0, or acceleration can be non-zero only if there is a net external force on the body. It means any object which is in rest, and if we are applying any external force, then what will happen? Object will move. If we are applying a force on the object, then object will start to move. It means there is an external force working on the object which change its motion. Means if object is in rest, then it will come in motion. If object is in motion, if direction of motion and applied force is same, then object's velocity will start to increase. If direction of force is opposite to the direction of motion, then what will happen? Its velocity may decrease. It means we can say that if any object is in rest, then it will keep in rest. If it is in motion, then it will keep in motion unless and until any external force is not applied on it. If we will apply external force, then what will happen? Its state will get changed. So it means we can say that Newton's first law of motion is also called as the law of inertia. Now comes to the second law of motion. Newton's second law of motion. Suppose we are having a ball which have mass m and velocity u. Now we applied a force. Due to this force, velocity of the object changed to v. It means if we are applying a force, then its velocity get increased. If we are applying an external force on the object in the direction of motion, then its velocity will get increased. But if we are applying a force opposite to the motion, then what will happen? Its velocity gets decreased. It means we can say that force is also proportional to the change in momentum of the object. Suppose change in momentum, it means we can say that F is proportional to m into dv. Force is proportional to the change in rate of change of momentum. That is also called the force. It means Newton's second law of motion says that the rate of change of momentum is proportional to the force is proportional to the rate of change of momentum. So now comes to the definition. The definition says that the rate of change of the momentum of the body is directly proportional to the applied force and takes place in the direction of the motion, direction of the force acts. So we can say that F is equal to m delta V upon delta T. It means applied force if any object, the rate of change of momentum of the object is directly proportional to the force. So, we can say that F is equal to m into delta V upon delta T. We know that acceleration is rate of change of velocity. So, we can write F is equal to m into A. So, another definition, we can say that force is equal to the product of mass and acceleration. So, we can say that force is equal to the mass and force is equal to the multiplication of the mass and acceleration. That is also known as the second law of motion. Now, comes to the third law of motion. Suppose there is a one wall and a man trying to push the wall with certain force, then what will happen? Wall will also apply equal and opposite force to the man. If we are pushing a wall with certain force, then what will happen? Wall will also apply equal and opposite force to us. That is called as the that is happening because of the action and reaction. It means every action have equal and opposite reaction. So, if we are pushing the wall, then it means wall is also pushing to us with the same force. That's why both are in equilibrium, means neither wall is moving nor man is moving. But suppose if we are applying a force which is greater than the strength of the wall, then what will happen? Wall will fall down. It means wall do not have the capability to resist our force. So, that's why wall got damaged. So, it means say that every action have equal and opposite reaction. So, if we will apply a force, then what will happen? Wall will also apply the equal and opposite force. Suppose any object which is on the ground, then what will happen? Weight of the object mg is in downward direction and ground will apply equal and opposite force, that is in upward direction. That is known as the normal reaction by the ground. So, this is happening because of the action and reaction. So, it means we can say that every action have equal and opposite reaction. Now, comes to the next. So, now coming to the definition, to every action there is equal and opposite reaction and they act on two different bodies. When one body exert a force on the other body, here man is trying to push the cart with velocity FAB, then here cart is also applying opposite force, that is equal to F minus AB. It means magnitude of the force is equal to FAB, but direction is just opposite. It means every action have equal and opposite reaction. From this diagram we can understand it in much better way. So, here when one body exerts a force on the other body, the first body experiences a force that is equal to the magnitude and opposite in direction of the force experienced by the second body. So, here with the help of diagram we can see that when man applied a force on the cart, then what happened? Cart is also applied equal and opposite force which resist to the balance to each other. That's why object is in rest and it is not moving. So, it means every action have equal and opposite reaction. So, this is also known as the Newton's third law of motion. Now, comes to the quiz. Which law is also known as the law of inertia? So, that is well known, that is law of Newton's first law of motion is known as the law of inertia. So, here Newton's first law of motion is known as the law of inertia. What is law of inertia? Any object have a tendency to stay in the same state, means object do not want to change its state, that is known as the law of inertia. Now, what is inertia? Inertia means the tendency of the object to stay in the same state. Suppose object is in rest, then it have a tendency to stay in rest. If object is in motion, then it means object have the same tendency, it means object have the tendency to keep in motion. So that is the, that characteristic is known as the inertia. Now comes to the answer, the tendency of an object to stay in the state of motion is known as the inertia. It is natural tendency of the object to resist any change in its state of motion. Now comes to the practical example, or we have seen in our real life example. So here in the case 1 we can see that when a tree is vigorously shaken, some of the leaves fall from the tree. The leaves tend to remain in state of. So we have seen that when we shake the tree, then what will happen? The leaves of the tree got fell down on the ground. So why this is happening? Because leaves have a tendency to stay in state, means initially leaves of the tree was in rest. So when we shaked suddenly, then what happened? The leaves was in rest, but the motion, but the tree got in motion. That's why the leaves was having the tendency to be in rest. So here we will feel rest. Now here we can see the answer is also rest, that is the correct answer. Now case 2. Case 2 states that when a bus or a train starts suddenly, the passenger standing inside it tend to fall backward. The passenger tend to remain in the state of initially man was in rest in bus, but at a sudden bus starts to move. Then what happened? The lower part of the man was in contact with the bus, due to which the lower part of the man was comes in motion at the same instant with the bus, but the upper part of the body of the man was in rest. So it have a tendency to keep in rest because of the law of inertia. So that's why man fell back in backward direction. So here the passenger tend to remain in the state of rest. That is called as the rest of inertia. That is rest inertia. Now we can see case number 3. The dust particle fly off when we beat carpet with a stick. The dust particle tend to remain in the state. So we have seen that when we are when we beat the carpet with the help of stick, then we have seen that the dust particle comes out from the carpet. Why this is happening? Because dust particle was in rest. When we just put the stick on the carpet, then what happened? Suppose we put a stick on this carpet, then this part of the carpet comes in motion at the instant, and dust particle was in stationary, that it was in rest. That's why when we beat this, then these dust particle comes to the out from the carpet. So it means we can feel here the dust particle tend to remain in the state of rest. Now case 4. The passenger fall forward when a fast moving bus stops suddenly. The passenger fall forward when a fast moving bus stops suddenly. The passenger tend to remain in, means a passenger, suppose a passenger standing in the bus and suddenly bus applies a brake, then what will happen? The upper part of the man, the body's upper part of the man was in motion, but the lower part was in contact with the bus, due to which the lower part of the body comes to rest with the bus, but the upper part was keep moving with certain velocity. It means this portion comes to rest and this is in motion, due to which man fell in forward direction when brake gets applied. So this is happening because passenger tend to remain in the state of motion, because initially man was in motion, means passenger was in motion, due to which the upper part of the body was in motion, and which uh, which tends to keep the body is in motion. But as the brake is applied, so lower part of the body was in contact with the bus, so it comes to rest, but upper part was moving. That's why man get fell down in the forward direction. It is happening because of the state of, because it is happening because of the passenger tend to remain in the state of motion. Now case number 5. Here case number 5 says that luggage is usually tied with a rope of the roof of buses, so that when the bus stops the luggage does not fall. The bags here tend to remain the state of. So we have seen that suppose luggage was on the roof of the bus and it is moving with certain velocity, it means whole the body have the got in motion, and when brake is applied, then what will happen, the part which is in contact with the bus comes to rest at the same instant, but the upper part of the bus was keep in motion. This lower part was in rest. When we applied a brake, then this part was comes to rest, but the upper part of the body was keep moving with velocity v. So at an instant, this part was in rest and this part was in motion. So it means its inertia of motion was getting changed. That's why object get fell down in forward direction. So here the bag here tend to remain in state of motion. Now comes to the case 6. When a car moving on a road and takes a sharp turn towards left, the passenger tend to fall towards the right. The passenger tend to overcome to change in. So here we can see that object was in motion. When object was in, means man was in car, and when it comes to the turn point, then what happened, the velocity of the object was getting changed. It means at the point of turn, the direction of velocity gets changed. It means here direction of inertia is getting disturbed. So the passenger tends to overcome the change in direction. It means the direction of the inertia is getting disturbed. Means object want to be stay in same state, but when object turning on the on any sharp turn, then its direction getting changed, due to which its direction of inertia is getting disturbed. So here we can say that the passenger tends to overcome to the change in direction. So it means we can say that inertia is of 3 types. The first is rest inertia, second is motion inertia, and third is directional inertia. Now here in this practical we can see that a coin is on the cardboard. When we suddenly pull this cardboard, then what will happen, the coin was initially in rest. When we just pull this card, then what will happen, the coin was tends to be in stationary state. That's why the coin fell down in the glass. It is happening because of the law of inertia, means rest of inertia. That is called the rest of inertia. Means the object is at the rest and prefers to stay and rest. It means it will not move with the card. That's why it got fell down in the glass bottle. Now here we can see in this diagram, the object in motion prefers to stay in motion. So here we just left the certain object on inclined plane. Then what will happen, this object will keep moving in downward direction. As when it hits to this wall, then what will happen? At a sudden, it either it damage to the wall, or some of the part of the ball will get jumped from this. Means this is happening because of the inertia. Now the tendency of the object to stay in state of motion is known as the inertia. It is the natural tendency of the object to resist any change in its state of motion. Now types of inertia. Comes to the types of inertia. There are three types of inertia: inertia of rest, inertia of motion, and inertia of direction. So in the three, with the help of these three examples, we have noticed that this is the example of rest of inertia of rest, this is the inertia of motion, and this is the inertia of direction. Because here passenger trying to change its direction, because the passenger was having the tendency to move in the same direction, but as car was turned, then due to this turn, the direction of passenger also got changed, due to which he got left in he got moved towards the outward direction. This is happened because of the inertia of direction. So the tendency of body to resist any change in its state of rest is known as the inertia of rest. Example: when a bus or a train starts suddenly, the passenger standing inside it tends to fall backward. The dust particles fly off when we beat a carpet with the help of stick. So these are the inertia of these are the examples of inertia of rest. The tendency of body to resist its change in its state of motion is known as the inertia of motion. So we have seen the example: the passenger fall forward when fast moving bus stops suddenly. A luggage is usually tied with a rope of the roof of the bus. Now here we can see the tendency of the body to resist any change in its state direction is known as the inertia of direction. So for example, when a car moving on road takes sharp turn towards the right, the passenger tends to fall towards the left. It is happening because of the direction of inertia of direction. List a few examples of the inertia of rest from your daily life. This is your homework. On sticking the coin at the bottom of the pile of the carom coin, when a striker, the bottom coin only moves while the rest of the pile remains the same. Now comes to the numerical. When body of mass 5 kg is moving with, when a body of mass 5 kg and moving with uniform velocity 10 meter per second, it is acted upon by a force 20 Newton. What will be its velocity after 1 second? How much force is being applied on the body by the source of force? Here it is given that body of mass m. So mass of the body is 5 kg and it is moving with uniform velocity. Initial velocity is given 10 meter per second. It is acted upon by a force F is equal to, here applied force is 20 Newton. What will happen its velocity after 1 second? So first of all we will find the acceleration. So we know that F is equal to m into a. So from this we can get a is equal to F upon m. Here F is applied force is 20 Newton and mass of the object, that is 5 kg. So acceleration will be 4 meter per second square. Now here we have to find the velocity after 1 second. So we know that acceleration is equal to final velocity minus initial velocity upon time. Here final velocity that we have to find, initial velocity is given 10 So substituting the values here, v minus 10 upon 1. So we will get a is equal to, v is equal to 4 into 1 plus 10, that is 14 meter per second. So we can say that the final velocity of the object will be 14 meter per second. And how much force is being applied on the body by the source of force? How much force is being applied on the body by source of force? So the source of force will apply how much force is being applied on the body by the source of force. So that is 20 Newton force is applied by the body. So how much force is being applied by the body by the source of force? So that is 20 Newton. Now second question, a body of mass 2 kg is kept at rest. A constant force 6 Newton starts acting on it. Find the time taken by the body to move through a distance of 54 meter. So here mass of the object, that is given 2 kilogram, and constant force, that is 6 Newton acting on it. Find the time. So we have to find the time taken by the body to move distance through d is given 54 meter. So first of all we will calculate the acceleration. So here acceleration is equal to force upon mass. Here force is 6 Newton or mass is 2. So here 3 meter per second square will be the acceleration of the object. Now acceleration is v minus u upon t. So here value of a is 3, value of v, that is not given, value of initial velocity of the object, that is 0, and time is given. Time is, we have to also find the time. So here second law of motion says that s is equal to ut plus half a into t square. But here initial velocity of the object was 0 and we have to find the time. Acceleration we have already calculated. So substituting the value here, 54 is equal to 0 plus 1 by 2, value of a is 3 into t square. Now doing the calculation, so we will get t square is equal to 54 into 2 upon 3. So here t will be 6 seconds. So object will cover 54 meter in 6 seconds. Now do you have any doubt or confusion? Let's clear it. I hope everything is clear. So let's summarize the topics which we studied in this chapter. So Newton's first law of motion, it means every body continues to be in state of rest or in uniform motion in straight line unless and until compelled by external force to change its state of the rest of the uniform. And second, rate of change, applied force is proportional to the rate of change of momentum. And third is every action have equal and opposite reaction. And the fourth topic we studied, the tendency of the object to stay in its state, that is known as the law of inertia. And inertia was of 3 types. The first one is inertia of rest, second is inertia of motion, and third is inertia of direction. These we studied in our chapter. So I hope if you have any doubt you can ask. I hope it clears all the concepts. Thank you.